Hello, my name is Robert Smith, and I'm with New River Community College, and today we are looking at one of the fundamental questions involving solubility equilibria. In other words, that question is, when will a precipitate form? And to know that, we need to know a little bit about what concentrations and specifically how many moles are involved of the species that would complex to form a precipitate. In the case that's provided here, we have barium chloride and we have potassium sulfate. Potassium and chloride ions will stay in solution. They will not precipitate out. However, barium sulfate will form a precipitate. So what we need to do in this case is we need to calculate the concentration of barium ions and the concentration of sulfate ions in solution. We have 400 milliliters of 0.008 molar barium chloride and 600 milliliters of 0.006 molar potassium sulfate. So the first thing we need to do is calculate the number of moles of each species. So we'll start with barium, Ba2+. That's going to be the volume in liters, which is 0.400 liters, times the molarity, which gives us 3.2 times 10 to the minus 3 moles. And similarly, we can calculate the number of moles of sulfate, which would be 0.600 liters times 0.0060 molar, which gives us 3.6 times 10 to the minus 3 moles. Once we have that, and we know 400 milliliters plus 600 milliliters gives us a liter of solution. We've mixed them together, so now we want to calculate their concentrations. And it's easy enough because it's 1 liter, so the concentration of Ba2+ is simply going to be the 3.2 times 10 to the minus 3 molar. And similarly, the concentration of sulfate will be 3.6 times 10 to the minus 3 molar because we're dealing in 1 liter. And the KSP of barium sulfate is one that you would have to look up. The solubility product is 1.1 times 10 to the minus 10. So what we really need to figure out now is we have the K, so we need to figure out what the Q is. If you recall from a couple of chapters ago, Q is similar to K, but it's out of equilibrium. So we're not sure whether this is an equilibrium or not, so we're going to call it Q. Q is going to be the solubility product of these species. They're not the same, so they're not in equilibrium. Recall that when we calculated our solubility product, typically we use just S or S squared for 2 of them, and that's because they should be the same. In this case, they're not, so Q is going to equal the product between 3.2 times 10 to the minus 3 and 3.6 times 10 to the minus 3. And that'll give us 1.2 times 10 to the minus 5. In this case, we now see that Q is much larger than K. So when that occurs, we're assured that barium sulfate, in this case, whatever our precipitant is, will precipitate and it'll do this until Q is equal to K. is less than or equal to K. So it'll reduce the concentration of both sulfate and barium until such a point that Q is less than or equal to K, at which point it will no longer precipitate. Okay, that's it.